So the next presentation is from the Belgian computer vision company RoboVision. RoboVision aims to make the revolution between humans and machines possible for tomorrow's leaders with customized robot vision developments. Jonathan Berthe is the mastermind and driving force behind RoboVision and will now talk to us about the potential and benefits of collaborative intelligence for the smart city. So Jonathan, it's on you. Share your screen, activate your camera, and go ahead. So at least we cannot hear you, Jonathan.
Mute. Do you hear me right now?
Yeah, now I can hear you. Could you activate your camera?
Yes, I can. But no, the host has stopped it. You have to ask me to activate it.
Ooh.
Yeah, so
now
start my video. Do you see
Perfect.
it?
So the stage is yours.
Thank you. Thank you. So I'm Jonathan Berthe. I hope you can see my title slide. Can everybody see that?
Yeah, we can see it.
Okay. I'm the founder of a company called RoboVision.ai. We are active actually in 4 verticals: manufacturing, greenhouse robotics, smart cities, so safety and surveillance, and healthcare. But we started out in AgTech, actually, in agricultural technology. And because we had to make our platform so robust, because AgTech is not only in Belgium and the Netherlands, it's worldwide. We had to work with key stakeholders in Japan, Australia, Canada, where our machines are built. So we had to build a pretty big tech stack that was also scalable. And this scalability and this interaction between product specialists on one hand and the data scientist on the other hand is actually our key USP. It's what we call AI at scale. It's really important if you scale AI that you scale the underlying processes, because some of you might know, but a lot of these proof of concepts, they just miserably fail. A proof of concept is easy, production is hard, and it's because of this big challenge with AI. And this challenge is actually the gap between product specialists and data scientists. And we have actually put this into a new meme, collaborative intelligence. And with collaborative intelligence, we mean that product people on the work floor, on the shop floor, in the control room of a smart city, they have a lot of experience of day-to-day habits of how a conflict arises on the street, how a typical drug deal is done, how these things are actually effectuated. And we've tried to manage these kind of flows within one platform where these product specialists are working hand in hand with the data scientists. Because most AI platforms that you see nowadays are really data science oriented. They are intended for the people that have experience in data set creation, that have experience in all this. But if with our lessons learned in AgTech, for instance, in these smart city farms, there is not a single data scientist walking around. All of these robots, all of these machines are operated by non-IT savvy people that create deep learning models themselves. And what we saw at one point is that our stakeholders, our biggest customers, started to trade AI models between one another. They really started to sell them with USB sticks, and they corrupted our backup functionality. And then we said, like, oh, this is not the intent of our software. We have to do something with it. We have to actually use this kind of interaction that was started by customers to make AI stores. And that's, at this moment, one of the key USPs of what we would like to bring to the market. It is this interaction between stakeholders, not only the product specialist and the data scientist, but also different cities, different smart cities, different retail partners, different stakeholders in society that want to use a deep learning model from another partner. Because we know, and it's actually, I was listening carefully to the last speaker, and the questions and answers about it. If you have the challenge of autonomous driving, for instance, here in a German city, the problem is that this can never be done with heuristic rules. This, at this moment, with the state of the art in AI, can only be done by deep neural networks or related technology that can use gigantic amounts of data to be able to come up with what we humans call almost intuition. And it's this complete understanding of reality that is the promise of deep learning, and that is what actually needs to be productized somehow. So the RoboVision platform is actually a product where you can go from different data sets where you can label in 3D, in 2D, or even in medical, and where you can create these kind of engines together with the product specialists. For instance, here in elderly care, where we do fall detection, or here at the highway in Belgium, where we do tracking of things, or here in another situation, security, where our stakeholders can really learn themselves and create this dream of AI at scale by annotating, by training models, and by deploying them themselves. So I'm not saying that it's easy, but we try to manage a tech stack where all of these responsibilities are put into one flow. And of course, this needs different, how could I say, tooling. One of the tooling was also noted by the previous speaker. It's enhanced labeling tooling, not only boxes or semantic segmentation, but also magnetic lasso, also a GrabCut tooling like here, where you use machine learning to already predict what is probably the object at choice, and even 3D tooling for our customers in horticulture. Our next big thing in horticulture is actually the complete harvesting market. But here, of course, we are on the topic of smart cities, and smart cities have a lot of challenges. Not only the security of the people, but also traffic management, public hygiene, security and safety. A lot of these underlying models that we use are using PoseDetect, and of course with PoseDetect you also need the labeling, so we have enabled this in our platform that you can also do this for specific customers, this 3D and annotation tooling. But it's not only pose detection, as you can also see in this industrial case. It's also about emergency detection, like another case that we did already shown in the reel a little bit before, where this is actually being done for elderly care. A lot of smart city use cases are not only the challenge of open, how could I say, open space. They are about people and safety, and also happen indoor. Another use case that we have is danger detection. So we look for potential harmful elements that are being used in certain conditions. Of course, during the Corona times, we did the distance detection, so to see if the 6-foot rule was actually corroborated in an efficient way in Flemish cities, but also tracking of people on tracks. Traffic analysis is also a use case where we work together with the Agentschap Wegen en Verkeer in Belgium to enable this next stage awareness in the, for instance, tunnels for safety monitoring. For big multinationals, we use our tech stack for smart parking. But we also use the RoboVision platform to work on public hygiene. Public hygiene meaning plastic detection, littering detection, and that kind of stuff. So very challenging case because we need to, in every kind of circumstance, detect plastic on the water surface, which is absolutely not an easy case. We also use distributed labeling for our projects and different technologies. And this distributed labeling, we are using partners in all over the world, but we always try to see if our partners are working, for instance, in a good karma way, and if they are not abusing child abuse or that sort of case. So we try to really see that the labeling is done in good circumstances. One of the things which is also an interesting case is recycling. It's not really a smart city, but here we detect danger by detecting the gas bottles inside the streams. The case that I was talking about earlier is the COVID distance scanner. So here at the city center in Antwerp, it's being used. Another case where we showed the value of the RoboVision platform is inside Dutch infrastructure works. And I'm now going to, wait 1 second. Here you see this case where we do crowd monitoring to make sure that there is no attacker that leads to anomalies in the crowd. We're also working on the crossroad of the future here at the Antwerp Plantijn-Moretus-lijn, where we will have full awareness of all stakeholders inside the, how could I say, Antwerp city crossing. Just to conclude, AI is ready to be used at scale, but it needs the right tooling in order to go to all of the flows that are necessary to create a deep learning model. I think the previous speaker has done a great job by iterating these different steps. I've focused more on the different use cases. We also work with drone use cases, for instance, to do crop monitoring. Drones are also applicable in smart cities, of course, but there are some safety sensitivities, of course. A drone may not fall out of the air all of a sudden because it can harm people much more easily in a city environment than in a field environment. That's why we, at this moment, believe most of all for drone technology inside AgTech. Just small gimmick that I also want to show is the rose cutting robot. So the platform is not only used in smart city cases, it's also used in a lot of AgTech cases on a worldwide basis. Thank you very much. This was my talk. I think I'm within the limits of 20 minutes or just within these limits. And I'm open to answer your questions right now.
So thanks a lot, Jonathan. If you have questions, please again write them in the Q&A section. Again, I would have one question. So there is no doubt that AI is an integral part of smart cities and the application you showed us, but what are the building blocks needed to develop one?
Of course, you have the software side, everything related to deep learning creation, where platforms like Senten or RoboVision can ease these flows. And at the other point, you have, of course, the hardware on which it needs to be deployed. And then there are a lot of different, profoundly different approaches you can take. You can go for full edge deployment. in case of NVIDIA Xavier or even TPU edge devices, or you can go all out for streaming to the cloud via, for instance, 5G, that's what we're doing at the Antwerp case, and where you do the processing inside the cloud. Now, to choose one building block vis-a-vis the other is also a question of the requirements of the customer. It's not always, I mean, if a customer is really sensitive to internet outages, and if the production can go down, of course, he will not want to stream it to the cloud, because if anything happens with the glass fiber, then production can go down. But there are cases where the cloud can be used and where these building blocks can be reconfigured in other cases.
Okay, thanks. Another question which came up, so you showed use cases about collaboration or also with the elderly care, for example, and I think it's more a human question behind it. Who does ultimately take decisions if something happens? So how far is the AI itself involved in decisions? For example, a people is lying outside of the bed and do we get an alarm outside or something like this? So who makes the last decision on it?
Of course, it can never be AI. AI can only be a smart trigger, but the responsibilities, especially when you're working with human lives and lives in danger, and in some cases, of course, yeah, it must be a smart trigger that may not trigger too much or too often, because otherwise the people involved will think it's a false alarm where it might be a calamity or an emergency situation. But in the end, we're also working in healthcare cases. It is really important that a human is still in the lead, and that the whole thing about AI, and I'm talking about healthcare here specifically and smart cities, yeah, where AI is in constant interaction with humans. Yeah, there the human must ultimately be in the lead. And that's different in AgTech. In AgTech, we have these farms that can be really work autonomously for a longer amount of times, that can take decisions by themselves, because the cost in the end can never be a human life, whereas an emergency which was not flagged can lead to very nasty situations.
Yeah, clear, understandable. There's another question which goes in the same direction. So do you use the AI then also in tasks where safety of the people is involved? So also here as a smart trigger or something like this? So it comes to safety of people?
Of course, when, for instance, a helmet is not on, then there is a trigger that somebody may not enter a certain zone in an industrial situation, because the AI triggered that somebody's there in an unsafe condition. So in safety environments, AI can do a great job at flagging non-conform situations.
Okay, yeah, understandable. But also then, yeah, there is no one harmed if they do a wrong decision, at least. Yeah.
Indeed, yeah.
Yeah. Okay, so thank you very much, Jonathan.